Francisco, you're the first one in. Francisco,
Hello.
you're the first one in.
Oh, hello. How are you doing?
I'm doing fine. How about yourself?
Doing good. I couldn't hear you at first because I wasn't connected to the audio, but
Yeah,
now
I got you. I'm sorry I was a little late today.
it's all right. I was waiting for the email. I was looking and I thought at first I went through emails and I was looking thinking that you like sent an email saying you want to make it today, but then I didn't see anything.
No. What happened was my computer was acting up on me. It was I tried to download last night's Zoom meeting, and
Mm-hmm.
the trouble was it just was not loading up. So I had to go through the process of clearing out my browser, and it was a bit of a challenge.
Oh,
But
okay, okay. I
I'm
see.
in now. Aditya, Carson, Javier, how we doing? We doing okay?
Doing great.
Faye,
Yeah, I'm doing good.
Max, Saki. Okay, guys, what we're doing today is something that you're not going to see anywhere else in Chem 1 or Chem 2, but it's extremely important, all right? Sorry for that little sip there. I got 7 of you in here. Who's missing? Can you hear me now, guys?
Yeah, we can hear you.
Yeah.
Sorry, somehow I muted myself. And Trin's in now. And let's see who else. Might as well do this right now. Okay. Wednesday, Thursday. Faye's obviously here. Max is here. Charlie is, oh, damn it. I forgot to include her. Dudley's here. Carson.
Yes, sir.
Thank you. Samir. James. Arthur. Saki's here. Aditya. Francisco's here. Trin and Javier. All right.
Here.
Yep, gotcha. Okay. All
I
right.
just talked to James, and James is waiting for the thing to go through to join the session.
Okay, I'll catch him in a second or two and I'll mark him. Thank you, Max. Okay, what I'm going to do right now is probably the most advantageous thing I'm teaching you all semester. How many of you like to do graphing by hand? All right, what I'm going to do now is I'm going to put on a video from Dr. Warden. It's not the best video I've had, but it suffices, okay? And what it's going to do is it's going to teach you how to graph in Excel. Now, guys, you're only doing one graph this semester. Next semester, when you get into Chem 2, you have to understand, sometimes we're able to measure 2 things. And if we're able to manipulate equations, and that's literally what you're going to be doing in Chem 2, is you're going to be manipulating equations. And you're going to manipulate them so that you get the equation of a line. The reason we are doing this is because we know we can measure 2 parameters, can't measure the third. But if we're able to manipulate our equation, and if we're able to plot one of the things we can measure versus the other, we will get a straight line. And the straight line we get will have a slope, and that slope will be our third value. Does that make sense to you all?
Mm-hmm.
Okay, so basically, without further ado, I'm going to try and get the video uploaded. Right now, I am into course content. I'm going to go down to the spectrophotometric determination of a dye. Guys, I'm going to show it to you right now, but I fully don't expect you to be able to do it right after you look at this video. While you're in spectrophotometric determination of a dye, third one down, how to plot a graph in Excel. Okay, and I'm guessing you guys just could not hear. You couldn't hear a second ago, right?
Can still
Guys?
hear.
No, you can still hear me, but you didn't hear the video.
No.
Correct.
All right, so basically I have to go into stop share, share sound. All right, if you can't hear the video, let me know right away.
About how to use Microsoft Excel to create a graph. So in the food dye experiment, you'll be asked to make some solutions where you're going to find the absorbance of them. So what I have here is Excel. I opened up Excel, and what I made in this column, the A column, I'm calling it the X data. I'm calling the B column the Y data. In your case, your X data is going to be the molarity or concentration of your.
Okay, simply speaking, when you're putting things in the first column, that's going to be what is plotted as your X. When you put things in the second column, that is what is going to be plotted as your Y. The other thing is, some Excel programs, mine, doesn't like when you use scientific notation. So if you have something like 3.45 times 10 to the minus third, you got to put it in as 0.00345. Does that make sense to you guys?
Yep.
If you don't put it in that way, you'll get a straight line and you will get a slope, but your slope will be off.
Food dye samples, and B will be absorbance. That's why I label them this way, but generally speaking, you have X data in the A column, and Y data will be in the B column. And I made up some numbers. So again, this is not what you're plotting, but I just made up some numbers just for illustrative purposes. What I'm going to do, I'm going to highlight, I click, in this case, on the 10, I'm going to use my left mouse button, hold it down, go to your right, and then go down until you highlight all those cells. Now in Excel, you want to make something called an XY scatter plot. So an insert, at least in my version of Excel, an insert, there's a menu here where it says charts. And if you click, if there's a one here with multiple scatter, there.
Basically, there'll be a whole lot of symbols up here in this portion. What you want is this one. It looks like an X.
It says insert XY
Sorry.
or bubble chart.
It has like an XY graph, and it has a whole bunch of random dots there. That's the one you want to click.
Click the down arrow and select XY scatter. So in my version of Excel,
Sorry.
you can see what happens. As soon as I highlight it, click OK, and then it makes the graph for me. So these are all the data points that correspond to X data and Y data. If you move the cursor over one of them, you'll notice it says 30, 85. Well, that's this point right here, 30, 85. X is 30, Y is 85. So when you do this, you should have, for example, you might do 0, 0 for your blank. You might do your different molarities you calculated for your Lua red. And this will be your Y, then will be the absorbance you get from the spectrometer. Now what you want to do, you want to add something called a trend line. So basically what I'm going to do, I'm going to highlight over one, I'm going to hover over one of these points. I'm going to right click. And on my version of Excel, it says trend line. Left click.
The other thing you can do, if you come over to the right side of the graph, there's this thing that looks like a champagne glass. If you click on that, that will also give you a fold down menu.
Click. On the right hand side, now you have some choices. You do exponential, linear, logarithmic, polynomial, power, moving average. And by default, mine's selected linear. So I'm gonna leave that selected that way. And if I look at my options, it says forwards and backwards. You can leave those alone. We're not doing any forecasting. Set intercept. I'm gonna leave that alone as well too. You do have the option to set the intercept to 0. That is something you could do if you wish. I'm not going to, and I usually don't. Display equation on chart. That one you definitely want to check. And one below it, display R-square value on chart. That's up to you. The R-square value will tell you how linear your data is. I'm going to select it. You don't need to do this. And basically what happens if you
Yes, you do. You need to select the R value.
do that, if it's completely linear, completely correlated, you're going to get a 1.0 for this R-square value. The more linear it is, the closer to 1 it's going to be. In this case, I get 0.9929. That's pretty good. You can move it around. Basically move your cursor over it when it looks like a multiple arrowhead. You can left click. You can drag it to wherever you wish. Okay. That's how you make our chart, and that's how we get the trend line. So when you need your line of best fit, my equation, I got y equals 2.96x minus 1.8. So you're going to get an equation like this when you graph, when you find the line of best fit from your food dye. Now, we need to make the chart a little bit more pretty. So if I click on top here, if I click on the title, I can modify the title. So in my case, it may be, if you make, usually it's, y versus x is a reasonable title. You don't want to call it just chart 1. The title should convey enough information so I know what's being plotted. So maybe if this is your experiment, you might do maybe absorbance versus molarity of Allure Red, or something like that. Now you also need to give it some axes. Give it axes labels. So in my version of Excel, you have an option called Add Chart Element. So if I highlight here, and if I left click, I have axes titles, chart.
Okay. If you go over to the right of your graph, top thing will give you the same values.
Title, chart, data labels, among other items here. So I'm going to add, under axes titles, I'm going to select primary horizontal. And we get something like this. And I see it's covering up my numbers. So maybe I wanted a different option for that. Let me see. Okay, so it seems I want to keep it there. So if I make my chart, I can click on my chart. I can grab the window here. If I click on the chart, I can make this a little bit smaller, and now I can make it fit. Okay, so if you click, if your axis title happens to cover up the numbers, if you were to click on the main window of the chart here, you should see these chart lit up. If you hit the corner here, you can drag it smaller. You can make it so it doesn't cover up the numbers. Now you can click on chart title. You can double click on it, and now you can change the title. So this will be whatever your x-axis actually is. So in your case, it's actually going to be the molarity of your solutions. You can just call it molarity, maybe parentheses M, indicate the units, and close parentheses. Now we need to do the same thing for the y-axis. So add chart element, chart title, primary vertical, and there we go. And I see we have the same kind of problem. It's barely fitting on here. If you want to make it a little bit smaller, you can. See what that does. There it goes. So you make it fit a little better if you have to, if it doesn't already fit nicely. And now you want to change that. I'm hitting the backspace just to delete this. And I'm going to call this maybe absorbance. Again, whatever your y-axis is, you can call it that. And there you can click off the side, and there we go. That gives us our graph. And then we have proper labels. If you want to make it a little bit prettier, you can go ahead and change. You can change some of the different layouts. You can change colors. You can do all kinds of different things as well. Another option, if you would right-click on it, if you right-click on here, you can change its location. So it says Move Chart. So I'm right-clicking on a white space over here, click Move Chart. Now you can change it into New Sheet. If I do that, that creates now a new tab at the bottom of my screen called Chart 1, and there we are. And again, from here we can play with the sizing and so on to make it fit as best as possible. You can do that. We can change the font if you need to. You can drag this down. You can change the font size if you want to as well. You can play with this however you want. But anyways, this kind of gives you a basic idea to get what you need, especially how to handle this equation, the line that best fit. If you want to make that a little bit larger, you click on it. Let's see if I can enlarge the size. Oh, here we are. If you double click on the text box, double click on it, I can now change the size to make it, something whatever I want. There you are. So you can play with that. You can play with axes that way. Double click on the box, and there's options then to change the different sizes and so on. But what's most important, can you get the graph made? Can you get it set for linear? And can you get this equation set properly? That's what you ultimately need to be able to do. You will be asked to upload a picture of your chart. So once you've gotten to this point, take your phone or screen capture of some sort and get a picture of it, and then you can upload it with your report.
Okay. Are we good with that, ladies and gentlemen?
Yes.
Okay, just access it again. It's fairly straightforward on how to do a graphing. Believe me, I don't know about you, but I hate graphing by hand. And this is going to save you a lot of that hassle, okay? All right, so we're going to get into the meat of the thing. Before I do that, I got 90 here. Did I do roll already? Yeah, I did. Is Samir, James, or Arthur here? Samir, James, or Arthur, are you here? Max, I think James lied to you.
Yeah, I talked to Samir too.
I don't know what to tell you. They're not here. Okay. Now, we're using something called Beer's Law. And Beer's Law, simply stated, means that the absorbance is going to be equal to this funny looking E, an epsilon, which stands for molar absorptivity, times the cell length times the concentration. So this is the basic formula we're using for today's experiment. Now, if I have two different color shirts, are they absorbing light at the same rate? I got a royal blue shirt and I got a sky blue shirt. Do they absorb the light at the same rate?
No.
So the dyes that are making it appear blue are absorbing different amounts of the light. So this means there must be some factor in the dye that causes one compound to absorb light at a different rate from another one. That is a constant that we call the molar absorptivity, and it's represented in the equation by that funny looking E. Now, another thing, if we double the concentration of the dye as the light is going through, doesn't it see twice as many molecules?
Yes.
If it sees twice as many molecules, doesn't it make sense that it's going to absorb more light? Again, Faye, you're my designated yes person.
Yes.
Thank you. So if it's absorbing more light, then the absorbance is also based upon the concentration. Now, the third thing, if I double the path length that the light goes through, again, am I also not doubling the amount of molecules that the light is seeing? So once again, the absorbance is directly related to the path length, but we can control that. If every time we put something into our instrument, if we keep the cell length at 1 centimeter, we can control that, and we can literally drop that from our equation. Does that make sense to you all?
Yes.
Now, if I've got nothing in my cell, how much do you think the absorbance is?
Nothing.
Absolutely. So let's think about when we're plotting this. If we've got nothing in there, isn't our concentration 0?
Yeah.
And if our at our 0 concentration, we get no absorbance. Remember, the y-axis is the absorbance. So isn't the definition of the y-intercept where it crosses the y-axis?
Mm-hmm.
So if it's 0, my y-intercept is 0. And so I get my equation, my absorbance is equal to epsilon, my molar absorptivity, times my concentration, plus 0. What does that look like the equation of, guys?
Slope of the line.
Thank you. I'm sorry, I'm getting.
I just sent you a message.
Yeah, I got them. They're in the waiting room. They are joining us. They're joining us momentarily, Max. Thank you. Okay, guys. I'm sorry, did somebody answer my question?
Yeah, I did.
That slope of the line.
What was it, Max?
Y equals mx plus b is the slope of the line.
Well, no, it's not the slope of the line. That is the equation of the line.
Right.
Okay. And if I have it in this form, and if my y is my absorbance and my x is my concentration, then I'm plotting absorbance versus concentration. I'm going to get a straight line, and the slope of that straight line is going to be my epsilon, or my molar absorptivity. Is everything I'm saying making sense, guys? Does it seem reasonable?
Yeah.
All right, so what you are going to do, and again, like Dr. Worden's example, this is an absurd example as well. What you are going to do is you are going to make 4 solutions. You're going to make 4 solutions, and you are going to know what the concentration of those 4 solutions are. Then you're going to take each one separately, put them into the instrument, and measure what the absorbance is and record it. Then you are going to make a graph of the absorbance versus concentration. You are going to get a straight line, and that straight line is going to have an equation, and the straight line is going to have a slope. The slope is the thing that we need. All right. So after we've made that plot and gotten our slope, we're doing all that work just to determine the slope. So after we've gotten the graph and gotten the slope, what we're going to do then is we're going to take our Gatorade. If we throw the Gatorade into the instrument directly, it's too concentrated. We won't get good values. So we have to dilute the Gatorade so that we get it to a point where we get reliable values. So we're going to dilute the Gatorade. We are going to put it into the instrument, and we're going to measure the absorbance. Now, remember, my absorbance is equal to my epsilon times the concentration. I'm going to take the absorbance of my diluted Gatorade solution. I'm going to divide it by epsilon, which is the slope, and that will give me the concentration of my diluted sample. Questions so far? All right,
But are we dividing the
go ahead, Faye.
absorbency that we got from the student data
Yes,
by the molarity of the stock red dye that we got from the student data?
no, Faye. No.
I'm
What
just
you're going
confused
to,
what the values are.
okay, all right. Let me try and re-explain this. You have a stock solution. You have a stock solution of your dye. All right. You're going to put 1 milliliter of that stock solution that you know the concentration of. You're going to put 1 milliliter into a volumetric flask, dilute it up to 250 milliliters. Save that solution. You're going to take 5 milliliters of your stock solution, put it into another volumetric flask, dilute it up to 250 milliliters. You have your second solution. You're going to take your third solution. You're going to take 10 milliliters of your stock solution, put it into 250, hold on to that solution. You're going to take a fourth value. You're going to take 15 milliliters of your stock solution, put it into a volumetric, fill it up to 250. You now have 4 different concentrations made from your stock solution. Okay, Faye?
Mm-hmm.
Now you're going to take each one of those diluted samples and you're going to put it into the instrument. And you're going to read the absorbance of each one of those
From the spectrometer, right?
from the spectrometer.
Okay.
Now you're going to make a graph. You're going to graph the absorbance versus the concentration. I'm going to show you how to figure that out in a second. You're going
Okay.
to do absorbance versus concentration of those 4 samples. You're going to graph that. You're going to get a straight line. You're going to get the equation of that line. And the equation of that line is going to have a slope. The slope is the molar absorptivity. The slope is the epsilon.
Okay. Okay.
Got all that done. That's all done. Now you're going to work with your unknown. You're going to have a bottle of Gatorade sitting out in the hood. And you're going to dilute that bottle of Gatorade. You're going to take a certain amount of the Gatorade. You're going to put that into a new 250 milliliter volumetric. And you're going to fill it to the line. So you've diluted the Gatorade. The reason you've diluted the Gatorade is because if you put it into the instrument straight, it maxes out the instrument. So you got to have a diluted sample so that you have a reasonable absorbance. So you're going to take the volume of the Gatorade, put it into the volumetric flask, and you're going to take your unknown diluted sample, put it into the instrument. You're going to get an absorbance. Now, the absorbance you get from your diluted Gatorade sample, that absorbance divided by the slope we got from the 4 earlier samples is going to be the concentration of the diluted sample. Is everybody on base with this? Anybody confused? Good question, Faye. All right. First part, all we are doing is doing our dilutions and obtaining the absorptions. The only reason we're doing that is to make the graph. So we need to know the concentration of our diluted samples. We're going to use our old friend M1V1 equals M2V2. Guys, if you get into any kind of chemistry, pharmacy, anything like that, you're going to be using this equation constantly. Okay? We know what our stock solution is. That number is, that concentration is given to us. We also know how many milliliters of that stock solution we put into the volumetric flask. We're then going to add water until the volumetric flask. A volumetric flask has a big bowl down at the bottom, and it kind of tapers up so that it has a big long neck. Somewhere on that neck, there is a line. That line is going to tell you that when you fill it so that the meniscus is just on that line, that's going to tell you you have exactly 250.0 milliliters of liquid. So I'm going to know that my diluted sample has a volume of 250. I'm not going to know the concentration. So I have my stock solution. I have how much of the stock solution I added to the volumetric. I don't know what the new concentration is, but I know it was diluted to 250 milliliters. I do that simple math out. I have my new concentration of my first diluted sample. I'm going to do it with 5, 10, and 15. So that's the way I'm going to get the concentrations of my 4 solutions. Questions, guys? Any questions? All right. Again, if I were you, I would put the zeros in because I'm not certain that the scientific notation will work. Guys, your molar absorptivity should be in the thousands. If it is not in the thousands, then redo your graph. It's going to be in the thousands or 10,000, somewhere on that scale. Now, when you do your graph, you need to make sure that you have all these things labeled. If you have a graph, you have to put the title in. Basically, it's going to be y-axis versus x-axis. You have to identify what the x-axis and what the y-axis is. Absorbance, concentration. If your axis has units, you have to identify what those units are. In this case, absorbance has no units. Leave it alone. But concentration is going to be either in molarity or moles per liter. Scale. Basically, if you do it in Excel, it will automatically be done for you. But by the scale, I mean that you're going to have a certain number of blocks. That certain number of blocks is going to stand for a certain number of units. And the scale can't change from if you get 5 blocks is equal to 1 milliliter, then the next 5 blocks is going to be 10 blocks is equal to 2 milliliters. Does that make sense to you? The equation for the line must be somewhere on the slope. If you do the slope by hand, if you choose to not do the Excel graphing, that's fine. You can do it that way. But if you choose to do that, you have to hand calculate the slope. And when you hand calculate the slope, you cannot use the data points. Remember, Y is the absorbance, X is the concentration. The first column in your X will be your concentration. Second column will be your absorbance. All right. We've done our graph. We have our slope is 83,500 units. Our absorbance is 0.421. In order to get the concentration of our diluted sample, we simply just divide the absorbance by the slope we got. Now, we've diluted that sample. We really want the concentration of the original Gatorade. So right now, we know that the concentration of our diluted sample is what we just calculated multiplied by 250 milliliters. And that is going to be equal to our concentration of our original Gatorade times the volume of the Gatorade you put in the volumetric flask. In this case, I put 30 milliliters from my original Gatorade into my 250. I've got my concentration of my diluted sample times the volume, which was put in a 250 milliliter volumetric. That's equal to my concentration of Gatorade times 30. I do this math out and get my concentration. Questions, ladies and gentlemen? No questions. I'm going to stop share and I'm going to go into the individual results and post lab. By the way, I'm going to go down to student data first, if I can find it, student data for labs. Because there's a number I want you to ignore. Okay, there's the data. All right. Do you see this line here that says absorbance of stock unknown solution?
Mm-hmm.
All right. What they wanted you to do was they wanted you to get this unknown stock solution, put it into the instrument, and based upon what your absorbance is, what they wanted you to do was they wanted you to try and determine how much you should dilute it by. Okay? That's what they wanted you to do with it. Do not worry about it. Just forget about it. Do not even record it. All right? Forget this line. It'll just serve to confuse you.
So we're supposed to forget the volume of the unknown
No,
sports stream?
no. This line, Samir, that says absorbance of stock unknown solution, 2.51, I don't want you to use that because what it does is it serves to confuse you. Do not use that line. You're not going to need it for any of your calculations.
Okay.
All right? Go back to table of contents, hopefully. And really and truly, guys, this really is a simple lab. Yeah, he says that. The one you just did, the calorimetry, was that a pain in the ass?
Yes.
A little bit.
Pretty much. Believe me, I have to go grade those things today, so I know what a pain in the ass it is. So that was your last real hard one. This is what I want. All right. Results. Preview. Start quiz. Oh, I got these things. But this tells you I've been doing this too long. I have these silly things memorized. All right. First question. All you got to do is find the student data for lab, type in the molarity of your stock solution. All right. Next step. These are going to be your molarities of your standard dilutions. Just put the 4 values in there of the 4 stock solutions that you came up with. Part C, all you got to do is show me one calculation. And that's going to be M1 times V1 equals M2 times V2. You know what the concentration of your stock solution is? You know how many milliliters you put into the 250 flask. So the stock solution concentration times the milliliters you put into the 250 flask is equal to your new concentration times 250. Questions on that one? Second question. Equation of your line of best fit. Guys, if you do this in Excel, this is a gimme 10 points. All you got to do is print out the equation of the line and retype it in here. If you do it by hand, then you got to show me how you calculated the slope. And again, when you're doing the slope, do not use data points. If you use data points, why did you bother to graph it? Here is where you're going to be asked to upload your graph into the report. Remember, you need to have a title on it. Each axis needs to be labeled, and the concentration has to have units in it. This is where, if you want to put this number in, fine. You can put A 2.51. You're not required. The only thing I really need you to do, this part B is the absorbance of the diluted Gatorade solution. I need to know what that absorbance is. Molarity of the diluted sample. For this, all you're going to do is take the absorbance of the diluted sample and divide it by the slope of your graph. The slope is your molar absorptivity. So that's what you're going to do for A. For part B, again, you're going to do an M1 V1 equals M2 V2. You just determined what the diluted concentration is. You know that the diluted concentration was in 250 milliliters. And you know you put 30 milliliters of the original solution into the 250 before you diluted it. So all you got to do is take the concentration you just figured out, multiply it by the volume of your flask, which is 250, divide that by the volume of the original solution you put in the flask, which is 30. And that is it. Questions on the report, on the results? Fairly straightforward. What'll this take you? 15 minutes to do, guys?
Might take a bit longer. You have to
All
double
right.
check your stuff.
Okay. Fair enough. Now, the post lab. There's a couple tricky questions in here that I just wanted to go over with you. Okay. First question. You're going to have to read the introduction to get the answer to this. All right, your dye has a lambda max of 504 wavelengths. When you put something into a UV spectrophotometer and it absorbs light, it absorbs it in the case of like a peak, like a mountain. As it's starting to come in, as you're getting closer to the premier wavelength, your absorbance is starting to go up. It will go up until you reach the highest point, the highest absorbance that the dye is going to give. Then you're going to go off of that. You're going to increase the wavelength and it's going to start to go down. So you're going to have literally a peak that goes up and down again. What the lambda max is the highest value absorption wise, what the wavelength of the highest value absorption wise you get. Read through the introduction. You should be able to come up with an answer. One of these 4 answers should be right. The best answer. Okay. Second question. The answer to this is not obvious. You got to think about it. If the instrument is constantly reading 10% low on every absorbance, how does that affect your experiment? It's not an intuitive answer. Automatically, you're going to say it's going to screw things up. Think about it. Third question. You have a equation here. Your absorbance is equal to 3.800x. Okay? They're telling you, you have an unknown food dye solution. It's diluted. You put it in the instrument. Its absorbance is 0.65. I need to know what the concentration of the diluted sample is to 2 significant figures. Guys, somebody did an error last week, and I don't know why they did it. It was in the other class. What they did was they put the number in the answer and they put the scientific notation in the units. Do not do that. Okay? Just put the number flat out in here and the units in here. Do not use I think it tells you not to use scientific notation. Don't use scientific notation. All right. We have our 2 tough questions here, guys. Now, I got to explain what an LD50 is. When scientists are determining the toxicity of a substance, what they will generally do is they will generally use animals. And what they do is they keep on giving higher and higher doses to the animals. And that dosage at which half of the animals die is called the LD50. And generally speaking, that is considered the value that you don't want to exceed for humans. Does that part make sense to you?
Yeah.
All right, now calculate the number of milligrams of dye in an 8 fluid ounce glass of the beverage you used in the lab. You're going to assume that the concentration of the dye is this small concentration. Really and truly, this is nothing more than a dimensional analysis problem. You know that molarity is moles per liter. Turn the 8 fluid ounces into liters. You have a conversion down here. Turn it into milliliters first, then turn it into liters. You're going to multiply the liters by your molarity to get the moles of your dye. Once you get the moles of your dye, you're going to multiply it by the molecular weight, which is 496.42 grams per mole. but you're not done yet because it wants the number of milligrams. So you're going to multiply the grams by 1,000 milligrams per 1 gram. Questions on this? Okay. If you're in the pharmacy, you'll be doing calculations like this all through pharmacy. Our next problem. All right. Now, the LD50 is an amount per kilogram. Okay. Your body is more than 1 kilogram. So we're going to assume in this problem that your body weighs 240 pounds. What you are going to be asked to do is you're going to ask to determine the number of glasses of this sports drink that you are going to have to consume to exceed the LD50 value. Okay? Our LD50 is 10,000 milligrams per kilogram of body weight. You have a weight of 240 pounds. First thing you got to do is you got to convert pounds to kilograms. Then you got to take the kilograms, multiply it by 10,000 milligrams per kilogram body weight. That will give you the LD50 in terms of milligrams. Then simply speaking, guys, you know that 1 glass contains 8 milligrams. You're going to determine, you know, the amount of milligrams that is going to be your LD50. All you got to do is multiply that by 1 gram over 8 milligrams. 1 glass over 8 milligrams. Questions, guys? That's all I got for you. That's really all I got for you. If you don't have questions, I don't have any more reason to be here. Samir and James. Samir and James?
Yeah. I'm here.
Okay, yeah. I got you marked in there. Now, did you miss anything from earlier that you don't understand?
I honestly, I don't know. I came in right when you started to explain the A 3 equals C, and then A divided by 3 equals C. So
No. A, that's not a 3. That's not a backwards 3. That's an epsilon. That stands for the absorption. Okay,
Oh,
Samir?
okay.
Now, the overall experiment, you are plotting absorbance versus concentration. Okay, Samir? You are diluting. You have a stock solution. You know what the concentration of your stock solution is. And you're taking amounts of that stock solution and putting it into a 250 milliliter flask and diluting it to the very top. Okay? That means you have 250 milliliters of your diluted stock solution. Okay? You know what the concentration of your stock solution is, and you know the volume of the stock solution you put into the 250 milliliters. To get the concentration of your diluted stock solution, you simply use M1V1 equals M2V2. Concentration of your stock solution times the volume of the stock solution you put in there divided by the 250 milliliters, which was the volume of your diluted sample. Does that make sense, Samir?
Yes.
Okay, you're going to have 4 such solutions. First one, you're going to put 1 milliliter of the stock solution. Second one, 5. Third one, 10. Fourth one, 15. So you're going to have 4 different concentrations of your samples, 4 diluted samples. You're going to put those 4 solutions in one at a time into the instrument, and you're going to get an absorbance that you're going to correlate with each one of those concentrations. Got me, Samir?
Yes.
Then you are going to graph it. Now, if you graph absorbance versus concentration, you're going to get a straight line, and that straight line is going to have a slope. The slope is going to be equal to your epsilon, or your funny looking E. Okay? So that's why we're doing the diluted samples. Does that make sense, Samir?
Yes.
You're doing the diluted samples. You're going to get a graph of absorbance versus each one of those samples. You're going to get a slope. Now you're done with it. Once you get the slope, you're done with that portion of the experiment. Now you have a separate solution. You have a Gatorade bottle. Okay? Now, if I just put the Gatorade directly into my instrument, it's going to max it out, and I'm not going to get a good reading. So I have to dilute that Gatorade sample so that I can get it on the scale of my instrument. All right, Samir? So I'm going to take a
All right.
certain amount of that Gatorade, put it into a new 250 milliliter flask, dilute it up to 250. Then I'm going to take that solution, put it into my spectrophotometer, and I'm going to get an absorbance. Okay? Now,
Okay.
the overall Beer's law equation is going to be absorbance is equal to molar absorptivity times the concentration. We just figured out what the molar absorptivity was by doing the graph and getting the slope. Okay? We just put our diluted sample into the instrument and got our absorbance. So all we have to do is take the absorbance we got of our diluted Gatorade sample, divide it by the slope we got from the graph. That will be our concentration of our diluted sample. We then take our concentration of diluted sample, and we have to realize we don't want the concentration of the diluted sample. We want the concentration of the Gatorade. But we know the concentration of our diluted sample. We know that it was put in 250 milliliters. And we also know how much of the Gatorade was put into that 250 milliliter flask. To get the final concentration of Gatorade, we take the diluted concentration times our volume, which is going to be 250 milliliters, and we're going to divide it by the volume of the Gatorade we put in there, which I think is 30 milliliters. Does that seem to make sense, Samir?
Yes.
Okay. Any other questions?
No, none for me anyway.
Guys, I got 6 others of you here. Dudley, are you understanding what's going on here? You came in late, or you came in and out, I noticed. Any questions, Dudley? You're muted, so I'm guessing no. James, you came in late. You have any questions?
I think I got everything.
I'm sorry, you cut out on me, James.
No,
You
I don't
good?
think so. Yeah, I'm good.
Okay, good. That's really all I have for you guys.
Thank you, Professor.
No problem. I'm
Thank
here to
you.
answer any questions.
I'll make sure I reach out whenever I have one that pops up in my head.
Please use the phone number 727-202-7275. I'm generally here because I don't have a life.
Yeah, it's a pandemic.
Same.
Same, literally same.
All right.
All right, be safe, Professor.
You take care, guys. Take care, Trin.
Thank you.
Dudley, you good? Dudley, are you there?
Yeah, I'm good. I'm good. Thank you.
All right. You understand what's going on with this? Because I noticed you went in and out of here a couple times.
Yeah, I was late, so I'm just gonna look at the video. later on, so I could get it.
If you don't understand it, just email me back or give me a call, okay?
Yeah, I will. Thank you very much.
All right. Y'all take care then.
All right, you too.